Yeah, I see not much people joined. Probably will just wait for another 2-3 minutes. Any questions or doubts while we wait?
Good morning, madam.
Hi, Balaji.
Yesterday, yeah, I have one doubt. Yesterday, we talked about cluster IP. If I have one node. In the node, I have one pod, and I have this pod is doing some operation. So cluster IP. Can you hear me?
Yeah, I can hear you.
Yeah. In case of cluster IP, it will access that pod. In case I have two container in the same node, each container has one pod. That is, first container has one pod, some doing some operation like addition, and another container has one pod. It is doing some operation for like subtraction. In case of cluster ID, how to access the second pod? Did you get my question?
No. What is the question? I mean, you have two pods. So you want to access pod 1 from pod 2 within the cluster?
Plus, no. Cluster IP is it same for both pod, right?
So if are both the pods replicas or both the pods are different?
Both pods are different.
Yeah, if both pods are different, then first thing you need to know is when you create the service, forget about the type. When you create the service, the label should match. So obviously, you are not going to have the same label for both the pod. So for pod 1, if you want to access, you will have a separate service and you will give a separate label for it, so that for pod 1, you will have separate VIP and separate service. And same way, if you want to access pod 2 also separately, so you will have a different label for it and you will create a new service and apply. So for both pod 1 and pod 2, you will have two separate services or internally two separate VIP. So that's how if pod 1 wants to access pod 2, it will be using the service VIP of pod 2. That way.
In cluster IP is same for two pods. So both pods have same cluster IP.
No. Cluster IP depends on the type of service. So that is what I'm saying is,
Okay.
if you have pod 1, for pod 1, you can create a service of the type cluster IP. Okay. And then for pod 2, you can create a new service of the type cluster IP. Both will be different. Got that?
Yeah, okay. I got it.
Any other questions?
Yeah, hi Adam, this is Kore here. Hello.
Yeah, Koday, hi.
Yeah, I have a doubt, Adam. If a pod is filled, then will it create a new pod, and will the data get transferred to the new pod? New pod? Will
What
it
do you
do so like
mean
that?
by, yeah, what do you mean by data?
I mean, like, if the pod is full, and what will it do? If I have a node and in that I have only one pod, if that pod is full, what will it do? Will it create a new pod on its own in the same node, or will it create another node and it will create a new pod in that? Like that, I'm asking.
No, different things that you are talking about. The first thing is, if you have a pod, if the pod gets deleted for some reason, this is where, if you go back, I told you, pod as a singular object doesn't have the ability to replicate or scale. So if you have used a deployment object or replica set object and created the pod, and in that, if you have told some replica as 1 or 2, then if the pod is deleted, it is the responsibility of the replica set object or deployment object to recreate the pod, because it needs to make sure that you will always have the same set of pod. Okay, so that is one point. Now, when it is creating the pod, it will not create a node. It will check on whatever the node which is available in the cluster, which node has the resources matching your requirement. On that machine, it will go ahead and create the new pod. Okay, so that is the pod. However, inside the pod, you have container. So this is where we know, suppose if the container gets deleted, the content inside that will also get deleted. So that way, if a pod is deleted, the container will also delete and everything inside will get deleted. So this is where you should think of using volumes. So now, if you want to create a new pod and a new container, and if you want to make sure the content inside that will remain the same, then you need to use volumes again for it. And that is what we will see today, wherein yesterday what we saw the volumes was to just map it to one host machine. Because as you are saying, what will happen is first pod will get created in machine 1. Assume that you have mapped the folder to that machine, but the new pod which is getting recreated, if it gets created on some other machine, then the volume that you have mapped is on first machine, not on the second machine. So that is where when container or new pod comes up, the same data will not be available. So for this, there is a second type of volume that we have to see. Okay, because yesterday we saw only two volumes. One is sharing volume between containers of the same pod or sharing it between the host machine on which it is running. So the third type of volume, which is what we call it as persistent volume, which we will see today. But other than that, clear with what or how the pod will be created. For that, you need to define the object.
Different. But I have another doubt, Adam. Is this the same case when a pod gets down also?
What do you mean by down?
Like a server down, like something. If a pod gets down, will it goes to the another? Will it creates another pod, or will it?
That's what a server going down is different. A pod going down is different. Okay, so when you say pod down, I'll talk about the different status. For any reason, if the pod is crashed or the machine in which the pod is running is crashed, so obviously that means that the pod is not available. So in that case, if you have created the object or the pod with the help of an object like replica set, then you don't have to worry, because the reason for creating replica set or deployment is to tell that you always need a fixed number of replicas running, right? So this is where if you say I want one replica, If that pod goes down or crashes or got deleted, it is the responsibility of the replica set to recreate. But in that, which machine it will create, so that is completely up to Kubernetes, so it will decide. But when it creates, how do you make sure that the content of that is going to be available the same? That is something which we have to take care of.
Thanks, sir.
Any other questions?
Adam, go there here.
Mhm.
I have another doubt, Adam. A node can contains many pods, right?
Mhm.
If I have two pods in a node and both the pods have the same port number, how should I define it?
So that is where you're going to use, while mapping, you're going to use different ports. Okay, so in fact, you are not going to access direct. So when you use service, then using service, when you are trying to put it on a host path, then for every service, you will be getting a new IP, new IP will be there, but along with that, you will also get what we call it as a new host path port number, right? So that way, what
Yes.
will happen specifically, if you use that port number, whatever the service that internally it is trying to map, the port will be different. So that way, what you access will be the service port, and what you will get redirected is to the pod levels port. So that way, if two different pods are exposing the port, it doesn't matter. But what is that you are mapping in the service, that will be different.
Okay. Can you please show that when you are starting the session?
Okay.
Thank you.
Okay, so yesterday, okay, so we saw this pod 8. Okay, so I have pod 8 with Nginx. So what I'll do, I 8. Okay, here I'll open the svc.yaml. So what I'll do here, selector, and just say, let's say, me. This is going to be, let's say, pod with that label. So let's put a label. Pod 8. Okay, and label name is pod equal to 8. Okay, and let me go ahead and say now get the SVC. So this is the port. Now this is the IP. Now this is node port. So now if I want to access the Nginx, if I use this port number on the host machine, I will be redirected specifically to the Nginx running on port 8. So do this. You can see engine is accessible using the first service. So the same what I'll do now. Pick pod 9. Now in the pod 9 we have Apache. So and we'll make a copy of SVC. Here I'll just do some small changes. I'll say metadata name is 2. Everything else is the same, but here I'll say the label is pod 9. Now for this, let's create a label. This time I'll apply this on pod 9. See this? So pod 8 has a label and pod 9 has a label, and this we will apply to SVC. So now this will create a new service. Okay. So now service 1 is pointing to Nginx, service 2 is pointing to a different pod in which you have Apache. Now for that, if I use this port, the same one, you should see the difference. So here, I use the same IP. You can see,
Yeah, okay.
same machine, the service port is different. So this is accessing Apache, whereas if I access this port, this will be accessing Nginx, because each one of them is connecting to different label and different pod. So that's where you need to know which pods to create, what is the unique label for that, and corresponding to it, what will be the service label that you want to mount.
Yeah, thanks. Yeah, got clear.
Balaji, this is the same thing you were also asking.
Yeah, okay.
Okay, so before we start, so actually now we just left with another 2.5 hours. Okay, and also I don't see that your machine or the VM is proper, because for some of the example I need some storage also, and we don't have a ton. So can we do this way, wherein like I was telling in the beginning, was considering the remaining 2.5 hours? We won't have time for practice, but at least I can just walk you through the concepts. Again, most important concepts I'll just walk you through. Wherein I'll explain and I'll show a demo. So what you guys can do is at least just go through and if you want to quick notes or something, you can make it. But stop me anytime and let me know if you have other questions. Okay, so that at least I'll show you everything and I'll explain it. You can practice it later. Will that be possible? Because we don't have time to go through everything if we try to practice like what we did. Is that fine?
Yeah. Yes.
Others?
Fine, Adam.
Okay. So now going back to what we were seeing yesterday. So when we say volume, we saw MTDAR volume, or we saw a volume in which you can map it to the host machine. So what happens now is, so let's say you created a pod and you defined a host path volume, and that will be mapped to some folder in a machine. Now, if the volume that you are using is not for sharing something from the container, but if you want something to put back inside the container, then you can use the same volume from the host machine. But what happens if the pod goes down, a new pod is created? Chances are that it can be created on the same machine or some other machine, right? Now, what happens if this pod is created on a different machine? And now the definition of your pod, it will go and try to mount a volume on the host machine, but that will be a different machine. So what will happen now in this machine? If it is creating a new folder, then it will be completely empty. So that is where whatever you had earlier, you will not be able to get back. So this way, if you want to make sure that you are trying to share something on your host machine folder, then you need to create a shareable folder across all the machines like the NFS. Okay, so like in your regular Linux box, you have your network file sharing, wherein you will create a folder and mount it on all the machines, so that in all the machines it will be the same. So that way, regardless of the pod on which machine it is coming up, you can make sure every machine has the same folder and the same content is shared. But it will be very complex because you have to create a folder which is available on every machine in NFS, and every machine should have a read-write access. So by mistake in one machine, if you delete this, on all the other machines also it will get deleted. So this is one problem. Second problem is, if I add a new worker, then in that machine also you have to add the NFS and make sure that the folder is mounted and accessible. So this is where, if you need a concept where regardless of which machine your pod is getting created, if you can make sure that your pod has a volume which is shared across all the machines in the cluster, then such a kind of volume is what we call it as persistent volume. Okay, so as the name says, persistent means it is the same. So when you take any machine, when the pod is getting created, regardless of the machine within the cluster, you should be able to get back the same volume and the same content inside the container. But for this, like I said, rather than creating the host path, which is going to be on one specific machine, you need to create it as a NFS. Suppose if I create a volume over the NFS, then that will become a persistent volume. That means on all the machines, it will be the same, and no matter where my pod gets recreated, the pod will have the same content because of this folder. But practically, As we move to more complex activities and we are not just going to use VM, we will now have a requirement to store it outside your VM. Because when I talk about NFS is going to be within the machine. This is when tomorrow, if I add another 4 machines to the cluster, I need to extend the NFS across all these 4 machines. Okay. So what's the solution for that? So this is where NFS is one way to create a persistent volume in Kubernetes. But if not, this is where when you talk about cloud, so what you can do is, instead of having a volume on a machine level like a NFS, what we can now do is we can create a storage on cloud like AWS or Azure, and then we can allow each and every machine in the cluster to access this cloud. So that way, now in Kubernetes, when we are creating persistent volume, you can create a persistent, or you can create a volume which can be on a cloud which is outside your cluster, and allow the pods in the cluster to access the volume which is on the cloud. So such a kind of volume which doesn't change, because for example, now you create a pod. The pod will store the contents on the volume, and the volume is actually on cloud. Now, when this pod goes down and a new pod comes up, now the new pod on a different machine will again try to refer to the same storage that you have in the cloud. So this way, what will happen? No matter where the pod is getting created, you will always have the same storage. And even if a new machine is added, you don't need anything to store in the file system, because all the machines in the cluster will get this storage common. So that is where, if you are making sure that a volume is available for a container every time it recreates and without worrying about in which machine it is creating, then we need to create persistent volumes. So that is where the third type of volume is persistent, because the first 2 points are not persistent. Empty dir and post path, if you delete, everything will go away. But now, no matter how many times I create the pod, I should be able to get back the same volume. Then you need to create it as persistent volume. Now, persistent volume is a new object by itself. Unlike earlier, for empty dir and post path, volumes were part of the pod, correct? But now, since we are trying to set something across the cluster, so we have to create a new object of the type persistent volume. Where is it going to reside? So it can reside on the NFS, or we can store it on the cloud like AWS or Azure. Okay. But what will happen for this is, if you are trying to create a persistent volume, then first you should go to the cloud, and in the cloud you should create a storage first. And with the help of that storage, in your Kubernetes cluster, you need to create a persistent volume object, which will be mapping to a storage in cloud. For example, in AWS, we have a storage called EBS. Okay, so EBS are small storages. Now, first in EBS, let's say I will create a volume of storage of 10 GB, for example. Then in the Kubernetes cluster, I can create an object called PV, or persistent volume. And for that, if I refer to this AWS storage, then if you use this persistent volume within your cluster in Kubernetes, you will get 10 GB of storage. And where is it going to be stored? It is going to be stored on the AWS, not in the cluster. Okay. However, what happens is, when you are working, you will not have just one persistent volume object. So what we will be doing is, we will be creating multiple storages in cloud, and for each one of them, you will be referring a new persistent volume object. So that way, in your cluster, you will be having pool of persistent volume. That means, what do you mean by pool? Collection. So now if you see, I can have different storages. For example, this might be pointing to a 10 GB storage on AWS. This can be pointing for a 20 GB. This can be pointing for a 5 GB. So this way, you can first create pool of objects, and then when you are creating the pod, we can refer to any one of them, and that will be the volume mounted to your pod or container, so that the storage will go there. But in Kubernetes, it is a two-step process. So the first step is you create a storage, and based on that, you create a persistent volume wherein you will be having multiple objects created. Now, this is where when you are trying to define your manifest file, which is your YAML for the pod, now you need a persistent volume object. Unlike your host path, what you are referred, now you need to refer to an object here. Now this is where in Kubernetes, if you actually see, you will have to do administration of this object, and you need to take care of defining the manifest file for creating the pods. Now this is where, if you are an admin and you have AWS access or storage in cloud, then one part of the work is first create the storage, and based on that create the volume. But when you are defining your manifest file or the YAML, there is another work. What you are going to do is you are going to create one more object called as persistent volume claim. So what do you mean by claim? So claim is an object which you define, wherein you tell what is the capacity of the persistent volume object you need. So that is what we tell it as claim. So along with your definition of how many pods you want, how many replicas in it, and which image to use, all those things, you also have to say what is the claim. And when you apply this, Kubernetes will read what is your claim policy, and based on that, on the pool of object, whatever the object matches your claim, it will create a pod by mounting that. Which means, for example, if I tell in my claim, I need a persistent volume to be mounted into some folder, for that I need 1 GB of storage. So the claim will check on the pool of object, which object has 1 GB storage, it will try to map that. For example, here, if I say 1 GB, then the persistent volume claim will have 3 options here, because all the 3 has 1 GB. But if I say my persistent volume claim is 20 GB, then these two doesn't have that much of storage, then it will go to the last one and it will mount it, because only this has 20 GB. So this is where creating persistent volume will be one task, and for defining a pod and doing a deployment, what is the claim that you want is what you are going to tell. So that is where there are 2 tasks that we do. But what happens now? Once you create the volume, you go ahead and create the persistent volume object, and then while defining your manifest, you can define what is the claim you need. So based on the claim, the Kubernetes will take any one of the objects available and it will mount to your pod. So that when this pod gets recreated, it's the same PV object which will be mounted, so that the data, whatever you want, will be the same inside the pod. Okay. So this is what we have to do. So remember this. Now, here, usually administrators will be creating persistent volume, and as a user or someone who's trying to do the automation for deployment, you need to define the claim. Okay. So to understand, so what we will do, we will have to now go back to this diagram. So first, I need to create a storage, and for this I will use AWS. So in AWS, I will create a storage, and then we will create a persistent volume object inside the cluster. And then while defining the YAML file, we will also define a persistent volume claim to tell how much of storage is needed for this pod. So based on that, it will try to create the pod and assign the volume. Okay. Now, to do this, since I'm going to use AWS, so I have to create a storage called EBS. So that's the reason I'll go to this dashboard, and in the storage, I'll create a new volume. Okay, so here what we will do, we will try to create a new volume, and I don't need 100 GB. So I'll just make it as 5 GB. Okay. Now, one of the challenge that what we will have to understand when we are using certain things in AWS is the machine where you have created and the volumes that you are creating for storage should be there in the same location. So that way, the Minikube, whatever I have created, I need to check where is this running. So it's running on AP South 1A availability zone. So the storage that I'm going to create will also be available on AP South 1A. So that's all. So go ahead and say create volume. Now this creates a volume ID. So we will refer this. But now what we have to do is we have to first create a persistent volume. Okay. Now for that, there is a new object definition that we are going to keep. So pay attention here. So now this is a new definition called persistent volume, and I'm giving some name for it. And what is the storage that you want to be available in this? So I'll just make it as 5 GB. And this is where is the storage available? So this will vary depending on the type of storage. So since we are using EBS volumes on AWS, so I'm going to use this keyword called AWS Elastic Block Store. And this is where you're going to give the volume ID what we have created. So I go back to AWS and take this volume ID. Right. And let's create this. What I'll do, I'll just define pb.yaml. Now watch this. If I say kubectl get pb, you should not see any object. When I say kubectl apply, so it creates a new object of the type persistent volume. And now if I try to do the kubectl get pb, you can see it has created a storage volume of pb type, and that is having a capacity of 5 GB. So this way, you can create multiple PV objects and put it as a pool. So you don't have to create a pool, just create multiple objects. It should be sufficient. Okay. Now, what is the next thing we have to do? So we have created the persistent volume, but now I have to define my manifest file and I have to define the claim. This is where to define a claim, you will again have a new object. Okay. So what we have to do now is we will learn something new. So this is the new object that we have. First, watch this. So we created the persistent volume. Now we are going to define a persistent volume claim. So here, all you are going to say is the type is persistent volume claim, right? from name, and the only thing is how much of storage you are referring to this claim. So I'm giving 1 GB. Okay, so regardless of how many persistent volumes are available, so whichever the persistent volume available which matches the claim, Kubernetes will assign the pod to this. Okay. So let's try to create this. See the YAML. Once again, to check whether there is an object available, if you say get C, so there is nothing available. Now we can apply. So it has created, and now watch what happens. If you go and say get PVC, you should see that there is a claim available, and this claim is already referring to the persistent volume object that we have created now. Okay, so internally it is referring because this is the only volume available in our cluster, and that also has 1 GB. So it has started to bound to that. Suppose when you are creating a PVC, if there is no persistent volume matching the policy what you have given, then it will not be bound. It will give you an error message. But right now, it says there is one persistent volume object which it has bound to. Okay, so now we have the policy and we have the persistent volume object. Now, all we have to do is create a pod and tell to use this claim so that automatically it will be mounting to this particular storage or the EPS volume. For that, we have to now define our deployment object. Okay, because now when I want a pod, if I recreate the pod should be having the ability to recreate. So that is where I'm now creating the object of the type deployment, and I'm giving the replicas as 1, and for that I'm giving the match label. Okay, but now look at the things to do. This is where first I'm creating a container, and while I'm creating a container, if you look at this, we are telling that I'm going to mount a volume, but unless the previous one, whether it is a host path or FTDLR, so in this you are giving the name of the claim. Okay, so when you give the claim and the name of the claim, what will happen when this pod is going to be getting created? It will try to search this claim, and with the help of this claim, whatever the PV object is available, it will give that reference. Okay. So that is what the claim refers to. So you can see, unlike earlier, you are not telling host path, you are just telling claim. So in the claim, whichever PV object matches the storage, what you have given in the claim, and that will be mounted inside your container. And this is where in the volume mount of your container, you are telling what is the name of the volume and where it should be mounted. So anything that you store inside temp persistent on the container, it will be stored into the AWS storage through this persistent volume. And if I recreate the pod will get the same content of your temp persistent from the AWS storage, which is what we call it as persistent. So what's this? So we'll go back. Create a PV deploy. So now what? We should get a new object. And this will create a replica set, and then replica set. Okay. Now this is the pod what we have. Now just to show you, pod name. And here, there is nothing available, but what we will do now, let's create a file. Now, I'm creating it inside the container. Now, where is this mount referring to? So it is going to refer to a storage through your persistent volume object, and that PD object is actually based on AWS. So now whatever you store in temp persistent is actually getting stored in the new EBS volume under Amazon or AWS. Okay. Now, to show you that, let me delete this pod. This is where we will delete the pod. But as soon as they delete the pod, the deployment object or replica set will try to recreate. Okay, so now you can see. So if we now go back into the pods, we should see that the new pod is recreated. And if I go inside this pod, and this pod, now this pod will get the same 10 persistent folder from the AWS. Now if I run, you can see you get back the same folder and the same content on it. So this is how, when you want a pod to have the same content no matter how many times it is recreated, then you're going to create it as a persistent volume storage. Getting it? Any questions on this? Any questions or doubts on persistent volume? How it is working?
How will be the data consistency?
What is it?
Data consistency.
Yeah, because where are you storing? If you look at this diagram, you created pod 1. In the pod 1, the temp persistent folder is referring to the storage that we have created in AWS. So now, whatever you store in the volume under temp persistent will actually get stored in cloud. So that is where when a new pod is created, if you go to temp persistent, it will be the same folder which is mapped again from the storage on cloud. So that is where it is consistent. So no matter how many times I create the pod, if I go to temp persistent, the data is consistent because where is it the volume created and referring? It is referring to a cloud storage which is outside the cluster. And that is what you see here. On the first pod, when I created a file, I deleted the pod and I created a new pod here. And on the new pod, If I go to this temp persistent, you can still see that the same file is available because pod is not there, but the storage is not inside the pod, that is happening on the cloud. So if I create another file, okay, so I'll create a file called test file from pod 2. Okay. So you can see there are 2 files. So now if I go ahead and delete this pod, and when a new pod comes, it will also be referring to the temp persistent of the same AWS. So when you go back to the new pod under temp persistent, you should see the same data from the storage on cloud is being mounted. So that is how it is going to be consistent.
Yeah, okay.
See, the new pod has come. Now if you go here, okay, pod. If I go under temp persistent of this, get back the same content which is coming from cloud. Okay.
Oh, yeah, okay.
Now, when you delete your objects, your persistent volumes will not get deleted. Okay, you can see this time I deleted the entire deployment object itself, so that it would have deployed the replica set and the pod also. But still, you have your persistent volume available intact. So that is where all you have to tell is when you are creating a pod, which persistent volume that you want to map. For that, you will use the claim. So in the claim, you tell the capacity. So that will go and search whatever the volume available and it will go on. And when you don't want, you should in fact delete all of them. Delete the persistent volume. On the other side, I should also delete this. Now, when I delete this volume, then the data is permanently lost. So that's how you should be deleting everything. But regardless of the pod getting deleted, the volume will be intact on the storage, which is what we call it as persistent. So it's always going to be the same. Okay, so there is another interesting topic that we have is health check. So if you go back to the beginning, I told you that why do we need a orchestration tool for managing your cluster? This is because now let's say you have a pod, and whether the pod is running or not running, Kubernetes will decide based on the label. And if you keep that object as what we call it as the replica set or replication object, so Kubernetes will make sure that it will have the same number of replicas always running. Okay. So with this feature, using replica set, what will Kubernetes do is Kubernetes will just check whether the number of pods is available. Okay, that's what it will do. But what will happen is at some time your pod and container might be running, but the container inside it or the application inside the container might not be running fine. So then what we have to do, it is not necessary for us to run the pod again. So we should be recreating the entire pod or the container. So this is where what will happen if a container is not running fine. How do we check that? Because if a container is running, when do you want to check whether it is running or not? That is another question, right? See, a pod will be running. Whether the same number of pods are running or not, Kubernetes will try to check and it will recreate the pod. But inside the pod, if a container is running properly or not, how do I check? And that is where we will be using a new concept called as health check. Okay. So using this health check, what we can now do is for every pod that you are creating or every replica you are creating, you can tell Kubernetes on a command or a script which will be having some specific command to validate the health of your application. Okay. So using this, the Kubernetes will run this command or script inside every replica of your pod. Okay. And how frequently you want to run this command or script, you need to tell. But once the script or the command is executed, how does Kubernetes know whether this pod or the container is healthy or not? Now that is where whatever the command or script that you give, it will try to run, and the written status of that command or script is what it is going to check. Okay. So what you have to do now is when you are creating the definition for your container, you need to also tell a command or a script, which is what we call it as a health check command or a script. And Kubernetes will run very frequently based on what is the duration you have given. And based on that, if the command or the script returns a 0, which is the exit status of that command is 0, then Kubernetes will consider that the container is good. Suppose if the command or the script what you have given in the health check returns a non-zero, then Kubernetes will consider the container is not healthy and it will recreate the containers. Okay, so that is what it is. So try to understand. So health check is a command or script which will give it to Kubernetes and ask Kubernetes to run very frequently on all the replicas of a pod. And every time when Kubernetes runs, if it returns 0, then the container is considered healthy. Whereas if it is returning a non-zero, then Kubernetes will mark that container as unhealthy and it will try to recreate it. Okay. Now, how do we give that? Okay. So this is where now, in fact, in Kubernetes, there are two types of health checks. Okay. So the first health check, what I'm talking about is what we call it as liveness prompt. Or what does liveness mean? Liveness means whether your application is alive inside the container. Probe means connecting very frequently and checking whether it is working fine or not. Okay, so this is where when you are trying to create your own pod definition, what we will do now, see this example. So I'm going to create a pod now. Okay. Now in the pod, I will give the definition, label, name, everything is fine. Now I'm going to create a container inside this pod where, if you look at this example, I'm creating a file called temp.lp and I'm running the container to sleep for 1000 seconds. Now for this container, I'm attaching a health check of the type liveness probe. So what will this liveness probe do? It will run the command or script, whatever you give, very frequently. And then if that is returning a 0, then nothing to do. And if it returns a non-zero, then this container will be recreated. So that way, for the liveness probe, you need to tell what is the command to run. Now here I'm just giving an example of running a ls command. So if this file is available, this ls will return 0. If this file is not available, this ls command will return a non-zero. Okay. Now in this, there are some options that I'm keeping, which is where the period second is nothing but how frequently this command should be run, which is what I'm saying, every 5 seconds. And sometime this command itself might get stuck or hung. So in that case, wait for maximum 30 seconds. If this command doesn't complete in 30 seconds, then mark it unhealthy forcibly. That is what is the timeout we are giving. Okay. Now, there is one more option called initial delay. So what is this initial delay? Now try to understand this. What is the meaning of running this command or script? If it returns 0, the application inside the container is healthy. If it is returning non-zero, it is unhealthy. And container has to be recreated. So this is where what happens is, as soon as the container is created, every 5 seconds this command will run. That means, let's assume that the current time is 10:10:00. Now when you create this pod and the container is running, exactly at 10:10:05 the command will run, and the next time it is going to run at 10:10. Now what will happen if this is not returning a 0? Then the container will be recreated. Now when will that happen is, what if you are having an application and the application takes 15 seconds to completely start? So that way, only when I run this command after 15 seconds, I will get the output of this command is 0. But if not, what will happen? On 5th second and 10th second, when I run this will be returning me a non-zero. So this is where what will happen? Your application is going to take 15 seconds to come, but within the next 5 seconds when this health check run, application is still not running, so your health check will fail. As soon as the health check fails, container will get recreated. Then what will happen? It will go into infinite loop. It will create container, run the check, it will fail. It will again create, check, fail. It will be doing this loop. But what we should be doing is, we should wait for first 15 seconds and then you should start running the check. So that is what is initial delay. So if I say 30 seconds, Kubernetes will not do anything for the first 30 seconds. That means once the container is created, it will wait for 30 seconds. And then from there, every 5 seconds, it will run the health check and check. So that is how, after this initial time, my assumption will be that application would have been started successfully. After that, I will run the command. At that time, if container is not running and if this command is returning a non-zero, then container should be recreated. Okay, so that is how, when you are doing this liveness check, you need to tell when to run, how frequently to run. At the same time, don't run it immediately, but wait for certain seconds. After the container comes up, the application should start successfully, and then we should be running the startup command, or your health check should be executed after some time. Okay. So this is how you make sure that your container has an application which is healthy. Okay. So to demonstrate this, let me just show you how the health check works. What's this now? Okay. So watch this, the container is getting created. Container is running. Now, if you go ahead and say or so here, if you scroll up, you should see it is going to run a health check of the command. Wait after 30 seconds, and then every 5 seconds it will run. And by default, the failure is 3. That means it will not immediately restart the container. It will run 3 times, and all the 3 times if it fails, only then it is going to mark and recreate the container. Okay. Now, everything is running fine. Okay. Now, what I'll do, just to show you, let me go ahead and delete that file, which is this one. Then healthy file I will delete. Then what will happen when the Kubernetes health check is going to run this command, and if it is not available, it will give you a return status of non-zero. So watch this. If I run this on my host machine, it will return, and if you look at the return status, it is non-zero because this file is not available. So for this, what I'll do, I will delete the file from the console. What's this? Okay. Now this file is not available. So quickly, if you try to run this kubectl describe command, see immediately after the 5th second when it tried to run the command, it is saying this is not available. So that way the help, that is the liveness probe command, is getting a non-zero. So that way it will try to run 3 times. Okay. And once all the 3 times is failed, it will try to recreate the container. Okay. So just wait. So this is how, what will happen is, you can see there is one restart of the container which happened exactly at 5 seconds. What happened? After 3 times, when it is failed, it is once again downloading the image and creating a new container. That is because when the health check failed for 3 times, then the liveness probe is going to recreate the container. Okay, so that is how for every container you can tell what is the health check, and only if the health check is success, Kubernetes will keep it running. If not, it will go ahead and recreate the container. Clear? Any questions? Getting it? Any questions or doubts?
No.
Okay. So however, when we say health check, right? So what do you mean if the condition is never met? Can you elaborate it? I didn't get.
Like we are doing health check, right? Where what if the condition is like the directory is never available, or
What is
we are
that?
doing some other. Can you hear me?
Yes.
Yeah. What if the directory is never available, or we are doing some other validation and that validation always fails?
See, that is what you need to know. Just to show you an example, I just gave this command called ls. But for your application to run, you need to know what is the command that should be validating whether your application is running or not running. If that command itself is not running, then it's very obvious that your application itself is not running. Correct? And that is where, if that command which you are running, if it is getting stuck and if it is not responding, then you are going to give the timeout so that if it is hung by this time, it is going to be forcibly timed out. That means your command will get stopped forcibly, which will also return a non-zero, then the container will be marked as unhealthy. So that is where you should know what is the application running, and for that application, what should be my health check command. Getting it?
Yes, Adam. Thanks.
Now this is where there is one more type of health check, which we call it as readiness probe. Okay. So what do you mean by readiness probe? So there's a small difference. If you give a command or a script as liveness probe, the only thing it will do is, if this command is returning true, or if this command is returning a zero status, container is fine. If the command is returning a non-zero, container will be recreated. However, let's say there is a web application. Now, your web application might be running, like there might be some process running or a jar or a var, something is running. So the liveness command that you give will check whether your application is running, but for some reason, let's say your application has to connect to a database or some other application or a service, which is not happening. Then what will happen? Just by running your liveness probe check, it will not be sufficient, because all you are checking is whether your application is running, but whether your application is ready for users to access, how do you validate? So that is what we call it as readiness probe. That means now, for example, if you have a service whip, if you are trying to access the service whip, it will redirect to the pod, right? In that case, if you give one more check called readiness probe, then what will happen? For the readiness probe also, you are going to give almost everything the same, but the command what you give or script you give will be different. But what will happen over there is, in case if the command whatever you are giving or the script you are giving for readiness probe, if it is failing, then container will not be recreated. So the readiness probe will not send the traffic to that particular pod. Okay. So now when you try to access your service, the service will not redirect the traffic to the pod, because Kubernetes will think that your container is not ready. So if you try to access, no traffic should be sent. So that is where, if you add one more health check called readiness probe, then the duty of the readiness probe is to make sure that if the command or script what you have given is running fine, then traffic will be sent to this container, which is what we meant by that your application is ready. In case if your readiness probe command or check is failing, the traffic will never be sent. So that way, it is going to be the same, okay, wherein the only difference what you are going to do is, instead of liveness, you can add one more called as readiness. Okay. And for that, you can use different kinds. Now I'll show you another type. Now one way is to run a command or script. Now once again, whether your readiness or liveness, you can run a command, or you can also check for a port availability. Okay. So in this way, here what I'm trying to tell is, run this container, and in this container, I'm saying wait for 10 seconds, and after that, let's say a period of 5 seconds again for this. And now every 5 seconds you are going to run this command, and in this I'm going to do a HTTP GET of port 80, which is nothing but, if I do a curl localhost 80 inside this container, if it is returning me success or 0, then I can consider my container is healthy and I can redirect the traffic. But if my health check, that is the readiness probe, is failing, container will not get restarted, but the traffic to that container will not be sent. And this is where now see what happens. So let me add this. So let's go back. So now what's this? So here I'm going to add the readiness probe. Okay. Kubectl. Okay. So you can see, even though the pod status here is running, if you look at this, it is telling 0 of 1. Why? Because unless and until your readiness probe is success, this container is not considered to be serving the traffic. So that's where pod will be there, container will also be there, but traffic will not be sent. And this is where you just go ahead and say kubectl pod. Okay, you can see the readiness probe failed. Now, because of that, clearly your pod is marked as not ready. So that's where, unless and until the readiness probe succeeds, you will not be having your container ready to receive the traffic. Okay, so that's where two types of check. So for every pod now you need two checks. One is liveness probe. So what will liveness probe do? It will run some command. If that is returning 0, it will keep your container fine. If that returns non-zero, it will recreate the container. Whereas if you have a readiness probe, if a readiness probe fails, Kubernetes will not send the traffic to this pod. Instead, it will be keeping it and waiting. Suppose only if the readiness probe is good and it is also returning a success, then your traffic will be sent to the pod. Okay. Now, just to show you quickly, let me delete this pod. So what we will do now, just to show this difference, here, instead of that health check command, so what I'll do, I'll just take this same exe command, because, okay. So I'm putting the same command so that your liveness will be success and your readiness should also be success. Okay. So now So it will wait until your readiness prop is running once. And when it returns success, then this will be marked as ready. Okay. See, it will run. So now you can see both the liveness probe is also success, readiness probe is also success for the first time. Then the container will be marked as ready, or the pod will be marked as ready for traffic. So this is where what you need to know is, for a pod that you are creating, you need to have the liveness health check to tell when the container should be recreated, and you need the readiness check to tell when the traffic should be sent to the pod. Okay. So that is how for every pod and every replica of the pod, you will be able to get this. So that is what health check is all about. So like this, every pod we can monitor, and Kubernetes will make sure that if that pod is not healthy, it will try to remove it. Okay. Getting this? Any questions? Okay, so if there's no question, then take a break for 10 minutes. Okay, so we'll sync up again at 10:45. Right? Okay, I'll talk to you in 10 minutes. Bye. Is it back? Okay. All right. So actually, I have another meeting at 12 sharp, so probably I might stop 10 minutes prior to that. Okay. So let's just try covering up remaining things as much as possible. Okay, so similar to health check, let me share this. Now, what happens when you are trying to run a container and the application inside it? Now, many times for your application to run, you might have to inject some configuration files, or sometimes you might have to inject some certificates, which is not going to be common across all the environment. So this is where, so let's say when you are creating an image, you will create an image with all the files and executables and OS that you need. And what you will do, you will also try to add the configuration files or certificates. But what will happen if you do this way, the image will have one common file, and the same file will be running across all the environments when you do a deployment or create a container. So out of this, now, for example, while creating an image, if I have given the database details of the configuration, which is related to a development environment, then what will happen? Every time I create a container in QA or stage or production, I will be referring to the same, I'll be referring to the same configuration file. The same way, if I try to create an image by adding some kind of certificates, okay, then the same certificate will be used across all the environment, which is wrong. So this is where what we need is, we need to have the ability in which we will create a container, and during the runtime, we need to have a facility to inject a file, which could be a configuration file or some sensitive data like some certificates. But now when you say, I have to inject it inside the container, how will you access the container? Because container will be created on different machines. So this is where you can think of using persistent volume, but using persistent volume for something like this will be too expensive. So that is where in Kubernetes, there is a new object to share such a kind of configuration files or certificates that you need. So in this, what we will do, if you know that your pod needs some certificates or configuration file, what you can do is you can create the file, which is a configuration file or a certificate, as a virtual memory file in the cluster. So instead of storing it physically in a file, we can create a cluster level. So what will happen? Now, Kubernetes will store this file, whether it is a certificate or whether it is a configuration file. It will store it in terms of some virtual memory. And if you go to any of the machine, this virtual memory will be available through which you can access this content of the file. Now, in that, Kubernetes has two ways to access this virtual memory. If the content of the file is small, then you can try to read the content of this file as an environment variable inside the pod, which is one method. And the second method is, if you want, where the file is a huge file, then the content of this virtual memory can be directly mounted as a volume. So then you can access it inside the pod. So this is how there are two ways in which this virtual memory can be accessed. So now what will happen? For every cluster, you need to create a configuration file for your application. Suppose if your application needs to run on dev, QA, stage, and production, then you will have 4 files, right? So in each of the cluster, you need to create a virtual memory with respect to the corresponding file. And then when you use the pod, you can tell to read it as a environment variable, or you can tell it to read as a file directly. So this is where, if you have a file like this, which is a configuration file or a certificate, instead of using the persistent volume, what you're going to do, you're going to use this new object called as virtual memory. Now in that, there are 2 types of objects. Okay, so that is, if you have a configuration file that you want to share across your pod, then you are going to use a new object called as config map. Okay, the same if you have some sensitive data like a certificate or a key store, then the object that you are going to use is called as a secret object. So both of them work in the same way. So whether it is a config map or secret, you are just going to give the file and it will be storing it in the virtual memory. But while accessing it, you can access it through an environment variable or through a volume. You can mount it directly. Okay. So this is where for your application, image will have only common things. But anything specific to environment like your configuration file or your certificate will be injected during runtime. Now to understand this, let me just show you an example. So what we will do now, first, I'll try to create a secret object. So let's assume for my application to run, it needs to connect to a database, and for that database, I need some username and password. Okay, now those details I will put it into some file. So what I'll do now, I'll try to show you this. Now I will try to create 2 files. One is username.txt and password.txt. Okay. So I'm just created 2 files. Now I want this file to be available on all the machine as a virtual memory. For that, I will create a new object called secret. And this is where I will tell create secret, and the name of the object is my secret. And then what are the files that you want? So practically I will take both the files together in one object. So like this, if you are creating a secret object, you can add as many files that you want, but the total size of this object, including all the files, should not be more than 1 MB. Okay, so you can take a single file of 1 MB or multiple files, but put together, it should be less than or equal 1 MB. So this way, now if I try to run, you can see it has created a new object. So if I say kubectl get secret, you should see this is a default one, you can ignore, but there is an object called my secret, and it has 2 data in it, which is nothing but 2 files in it. Okay, so now I can use this secret object as an environment variable, or I can put it as a volume and mount the entire file if the data content is huge. Okay, now this is where, how do I use it? So let's try both the ways for that. So the first way, what we will do, we will try to mount it as a volume. So now, when I go back to the concept of volume mapping, this is where if you see, so I have a pod and I'm creating a container. Now here I'm saying volume and I'm telling a volume name and where this volume should be mounted. But what is the source? So this is where now if you see another way of the source is I'm telling volume and the name, it should match here, but the type of volume is secret. So this way what will happen? Whatever the secret object that you created, the content of that will be mounted. So now if I go to the container under 10 MyScript, which is nothing but these two files. So this way, whenever the pod gets recreated, the mount will be available, and in that you will get back the same files available inside the container. So this way, when the container comes up, you can make sure automatically that it will be available. Okay. So let's try creating this. So we'll call it as secret.com. So let's wait for a few seconds to start that. So now if it has come up, I go to Kubernetes, the pod. Let's go inside. Okay, so I'll say item 90. So I'm inside the container. So if I go to the temp folder, you should see a folder called My Secret. If I go inside My Secret, you can see these two files are available. The one that we created and added as a secret object. And if I look into this, see, the content is available. Okay, so this is how, if you have some file like a sensitive data, and if you want it to inject inside your container during runtime, and regardless of when the container is going to start or which machine it is going to run, we can mount it using this secret object. Okay, so which is one method. Same way, now let's assume the file content is small. I don't need to mount it as an entire volume or full file. Then you can take this object and inside the pod, you can read it as an environment variable. Now for that, if you again go back to basics, so we created environment variable. So if you look at the syntax of that, for every container, okay, look at this example. So this is a pod and this is a container. Now I'm creating environment variable. Now earlier we were doing a hard code of that. Now instead of hard coding, so what we are trying to do is we are trying to take the value from a secret. Now in that, when you have multiple files in the secret object, so each file is called as a key. So we are telling there is an environment variable I want to create during runtime, but the value of that I should be getting from this object And in this object, the key is nothing but the file name. So that way, it's going to create the environment variable with the content of this file. So that's where we had put the name as root, right? So when you create the container, so inside the container, you should see that the environment variable is available and the value of that is obtained from the secret object. So this way, automatically every time when a pod is getting recreated or container is getting created, you will get this value automatically in a cluster. So let's try this also. Let's say secret. Pods. So once it comes, just go inside Kubernetes. ADNB, it will show you all the environment variables. Now, out of that, you can see the value of this environment variable is root, which it had obtained from this file, which we have stored in the secret object. So now, whether you are running your pod on a dev environment or a QA environment or a stage or production, if you need, let's say, some sensitive file like key store or some certificates, then specific to each cluster, you have to create a separate secret object and you need to have copies of YAML file for each of the environment. Suppose if I'm running it on QA, I will have a separate YAML file, and in that, I will give the object name that we have created for QA. So then when you try to mount it or read it, it will try to read the content specifically from that secret object which is available in the cluster. Okay. Now, when I was talking about config map, it's also the same. So there is no difference that you will see, but I'll show you why it is needed. Now, to work on this, what we will do, we will try to create an object called config map. Now, when do you use the new object called config map? So whenever you have some application configuration file needs to be injected. When do you use secret object? Whenever you have some sensitive data like certificates or key stores, you are going to use secret object. Okay. But if your application needs some kind of configuration that you want to give in runtime, then for that you can create the object called as config map. Okay. Now, the same way, how secret object is available, this config map object is also going to be available across all the machines in the cluster. Now, to show you this, now let me create a simple file called sample.com. Okay. So here, content. Now what happens? It creates a new object. So if you say kubectl get config map or CM, you should see there is one object created, and in that there is one file which is having the. Now this will be shared across the cluster as a virtual memory. Okay. Now, how to access this? It's the same way where you can take a volume or the environment variable. Okay. Now, suppose if I want to access this file inside my container, then like I said, you can use the volume method or environment method. Okay, both are going to be the same. But what will be the keywords? There will be a small change. So now assume I want to access this, and usually when you say configuration file, there will be a lot of content. So accessing it as an environment variable will not be a suggested way. So then I need to access it completely as a file. And that's where, if you look, mount this to a folder called config, and for that we need a volume. And this is where, when we are creating the volume, you are telling to refer config map object. Earlier we were using secret, now we were using config map. And in that, you are telling the name of your config map and then which file that you want to take, which is what is going to be the key. So now when you create this pod and the container, wherever it creates, you should see that inside the container under temp config, you should have this file available. What's this? So I'll put it as cm dot. Okay. So the previous one is also running, but this is what we have. Just take this. If I say or inside container, you should see config. Now under the config, you should see a file. If you try to cat this, you should get the same content from the object. Okay, you can see everything is available. So now it might be confusing. Okay, when should I use config map or when should I use secret? The first difference is, if you have a sensitive data like a username, password, key stores, or certificates, then use the object as secret object. If you have more readable configuration file, then you use config map. Because if there is a sensitive data, when a user is trying to access your cluster, they will not be able to see the content. So to understand that, when I say kubectl get config map, this is my config map, right? So see what happens when I say kubectl describe the config map and the name of my config map. So when you describe, you can see it is showing you the content of the file directly. Okay. So what will happen if you had some sensitive data, like I said, like key store or some username, password, or certificate? Then if I have access to the cluster, so pretty much I can just directly read this certificate, and if I put it in some other location, I will be able to access your QA or production. So which is where now, if you have sensitive data that you want to put inside container, then when you use secret, so watch this difference. The same object, when you create it as secret, when you try to describe your secret object, it will not show the content. So whereas the config map was showing it, but when you use it as a secret object, it will not show. Okay. So this is how, what you can do. You have to understand what kind of data you want to inject with respect to a pod. If it is sensitive data, make it as secret object. If it's more of a configuration related data or the application to start, then you create it as a config map. And to access, you can access it as a volume completely, or you can read it as an environment variable. So this way, whenever the pod comes up, you will have these files inside your pod, regardless of whatever machine it is. Getting it? Questions?
This is Preeta here. I have one query. Can you able to hear me?
Your voice is not audible. Can you come again?
Yeah, can you able to hear me now?
Yeah, I can hear you.
Yeah, this secret file is only for related with this SSL handshake certification related process. So we have to maintain this key store for that secret file and then common configurations for config map, right? The two files we need to uh, maintain separate file for that configurations and then SSL key store related things. That's what you are saying, no? That secret file.
Correct. So when you have your SSL certificates, right? So any kind of certificate, use it as secret. But for your application, if you are passing some XML file or a JSON file or a text file which has the configurations for starting the application, then those you put it as config.
For the container wise, if I have a different property files, so whether it should be a common property files for all the application node and whether I can able to maintain different property files. Is there any possibility of the?
That is your application specific. Kubernetes doesn't care. If
Yeah, it
you
is not a
have,
mandate, right?
Kubernetes doesn't care about all those things. If your application needs different files, then you have to create different objects, and based on that, while creating the pod, you have to mount. If not, if you refer, like for example, there is a common set of files for all the applications, then you can just create it as one config map object and refer in your pod definition the same for everything.
Okay. And one more doubt, the cluster IP, I have a 4 application node. So whether I can map two application node for one cluster IP and then I can able to create another cluster IP and then I can able to map it for another application node. So whether cluster IP should be a one, anything is there, or otherwise we can create a multiple cluster IP.
See, cluster IP indicates that you are accessing some pod. Now, what are the pods that your cluster IP should be pointing, or your service? Forget about cluster IP. Your service is going to point. So, cluster IP is a type of service. Suppose if you have two applications which you want to refer using the same WIP, then you should have the same label on all the pods so that whenever you access your WIP of the service, so that will try to do a redirection or a load balancing among all the pods that you have. So that is your call. But ideally, if you want to access both of them separately, because if you do not have the service IP, let's say, now how do you access each of the applications separately? Are you going to use one port and access both the application, or for both the applications you have separate port? Then you need to have separate services for each one of them.
Okay, so in one application node, I have a two pods. For that each pod, I have a different container. So one pod I'm having container 1 and then another pod is the container 2. So both I have a different port. So that time, whether I can create a two IP cluster IP and then I can map it for the each pod, which is there in our runtime.
Yeah, if you want to access both the pods separately, then have two services created for each one of them. And based on that, you will get two separate IPs and you can access each of the pod using each unique IP. So that is completely on what you require. So if you want to access separately, then create two separate services for each pod, one service.
Okay. So, and one more doubt. So, application node, we have a multiple pod, right? In that node itself, maintain the load balancer. Otherwise, we have to create a load balancer for routing
The
that request to
service
all the
will do a
pods.
load balancer. Within the cluster or the service itself will do a load balancer.
Okay. We don't need to create any load balancer explicitly, right?
So that is
It is the
another type of access. Outside the cluster, if you want to do load balancing, then you are going to have one more load balancer on top of service. But if you are trying to use node port, so directly if you access the node port, so that itself will do a load balance. But suppose what will happen, your application might be having different ports, then what will happen? So using service, you can access only one port, but your application might have more than one port, like you might have a management port, you might have a debug port. Now for those kind of things, you need to create two separate services and both of the service can be referred as two individual endpoint on your load balancer. That means your load balancer can have two endpoints and each endpoint can refer to one service. So in those scenarios, you will be using load balancer on top of your service.
so like cluster IP ingress is one of the concept, right? That is also for routing we will use. Otherwise, that will be the different.
Okay, I think you're stuck with the cluster IP. Cluster IP is a type of service in which you are going to get the ability to access the width of the service within the cluster. That is what we call it as cluster IP. If you want to access the service outside the cluster, then you have to make it as node port or load balancer. If you make it as cluster IP, you will not be able to access it outside the cluster. But within the cluster, if you have more than one pod referring to the service, it will do a load balance.
Okay, okay, thanks.
Okay. So we saw config map and secret object, and we saw health check, right? And we in fact saw type of persistent volumes. So the only important topic left for now is namespace. Okay, so that you will be able to understand all the basics. Now, what happens when you go to a cluster? What we saw was we were creating pods and we were creating different types of objects like deployment object, replica set, and config map, secret, right? So what happens now? Within a cluster, you can actually make groups. Okay, so what do you mean by group? So you can divide your cluster logically into some groups called namespace, and in fact, each and every object that you are creating now should be part of some group. So this way, what will happen? when you create a pod has to be within a group, which is what we call it as namespace. So why do we need to do such a group? This is because when you're trying to access, you will not be able to access the objects within one pod from another pod directly. So that way, now if you're creating a big cluster, and assume I'm having a cluster in which I am running different applications for queuing. Now, for each of the application, I need different pods, I need different replica set, different config map. Now, I don't want to mix everything. The reason is sometimes you might have the same name, same label, then it will be confusing, right? If I try to give a same label to everything, then what will happen? All the labels will match. So that is why logically, when you are creating any object in Kubernetes, you will put them under a group called namespace, and you create the objects like pod, config map, secret, and then your replica set. Everything will be within a namespace, and whatever you see is you are going to manage everything within one namespace, and the other namespace will not be knowing anything about it. So this is how you can run all the objects and applications separately within this group. So that is where, as you start using your cluster, you need to first know this cluster will be used for different products, and then for every product, before you are going to create a container or a pod, what you have to do first is you have to create a namespace, and within the namespace, you are going to create all the objects in pod. And in fact, there is also a concept called as access control in Kubernetes administration. So in that, what we can do, we can tell a person can work only on one namespace, so that if you are a person working on a particular product, and I can create a namespace and assign to you, so that once you go to the cluster, you will be able to access only that namespace and the objects inside it or pods inside it. You cannot access anything outside that. So that way you can logically group all the objects and pod inside your Kubernetes as a namespace. And so far, when we are under namespace, so this is where if you do kubectl get ns stands for namespace, you can see there are already so many namespaces available. In that, we are working on a namespace called default, and that is where whatever commands you are running, watch this, all of them is getting executed in your default namespace. So when I say kubectl get pod, it says there is no pod found in your current namespace. If I say kubectl get deploy object, it will say nothing is available in your current namespace called default. Same way, if I'm just trying to delete some pod, okay, just to show you, kubectl delete. So it will say under your current namespace called default namespace, there is nothing available. Okay. So this is how any commands that you run is in fact running on a default namespace. So now what we can do, you can create a new namespace and you can define all the objects to be created under that. To show you that, now what I can do, okay. Now, again, I can write a YAML to create a new namespace. So watch this. So I'm going to create a new namespace called demo. And for that, I'm applying a label. If I apply this, it would have created a new namespace. Now watch this. If I say kubectl get namespace, you should see a new namespace available. Okay. Now, specifically, if I want to run some command on this namespace, then everywhere you have to add -n and the name. So now you can see, if I just say kubectl get pods, it's running against our current namespace. If you want to run the commands against a different namespace, then you can run this. Same way. Now let me apply this pod. So now when I apply this pod 1, now it will be applying on default namespace. Instead of that, if I want to run it under demo, then I can just say -n demo. So you can see it says pod created, right? But see, when I say pod get pods, kubectl get pods, on my default namespace, it says nothing is available. So instead of that, if I say kubectl get pods -n demo, then you can see it is available. So this is how, if you try to run any commands, it is going to be against a namespace. So that will be your default. But if you want to run it against a different namespace, then basically you can try to put it on the -n and say you want to run against that. Okay. Now, what we can also do is, all the basic commands that whatever we are using will be still holds good. Suppose if I want to delete it, okay, then what I can do is, now for example here, I want to delete this pod. Now if I just say pod 1, it will give me an error because on the default namespace there is no such pod. So instead, if I say -n and the demo, you should see the pod is getting deleted. So that's how specifically you can define where is that you want to run. But it might be little tedious because every time when you are running a command, you might have to add -n. So for that, there are two things you can do. One is, while you are defining any object, under the metadata, you can actually add a keyword called namespace and then give a namespace name. So then when you run it, what will happen? This will get created under this namespace directly. Okay. So which is one way of telling instead of saying -n. If not, you can switch the context of your namespace, because right now we are working in the namespace called default. So what you can do, you can simply switch it. So to switch, you can use this command called kubectl config and it will simply switch. Okay. And to check on which namespace you are working, you can use this command called kubectl config view and it will show a JSON output. From that, you can try to get the namespace string. So you can see right now you are in demo namespace. So now if I just say kubectl get pods, it won't say default, it will say demo. So this is where now if you want to run anything here, I can simply go ahead and say run. So now everything will be referring to your current namespace, which is default. Same way, if I want to delete everything with my current one. Okay. So remember this. Going forward, when you are running any commands or creating any objects, it is going to be within the namespace. So this is how logically we will be creating a group called namespace. And while you are running any pod, you need to decide on which one that you are going to run. So you can create a namespace for an individual project, or you can create a namespace for play, but you might have different environment. Like for QA itself, you might need 2 environments to run, or for performance, you might need. Then what you can do, you can create different namespaces out of this. So that's how logically what will happen, you are going first create a namespace, and within that you are going to run all your objects. And later on, as an administration, if you're going to do, you can give specific access also to that. Okay. Now, if you go back, so there is other namespaces, right? Now, if you look at the other namespaces, you should be getting this point, because in Minikube, where is that your other components of master and your worker machines running? That is API server, controller, etcd, scheduler, kubelet, kube proxy, or proxy server. Now all those things are also running as pod, okay, and they will be running under different namespace. So that is where, as a user, when we are trying to run, we are not able to see anything. But if I do the same thing under kube system, so you should see all your components will be running. Your etcd, DNS, API server, controller, scheduler, and storage, and the proxy server. So now if you understand, if all these things were visible to you directly as a regular user, if you mess up something with this, then nothing will run. So that is where what will happen is we need to run everything logically into separate namespaces. Okay. So only then you can watch what is running, where it is running, and you can have a control of everything under that. If not, what will happen? It will be difficult for us to access everything. Okay. So now going forward, if you are going to create a deployment, so what you have to do first, you need to define a YAML file which will have everything needed in it. Okay, so now you should have a clear understanding. First, for doing your deployment, what you need is a Kubernetes cluster, and in that you need first an image. So for that image, you need to take your build, and from the build, you're going to kind of put all the layers that you need and create an image. And to run that image, you need to define a YAML file, which is what we call it as the Kubernetes manifest. So in that, you need to first understand, okay, what is the image that I'm going to give? For that, is there an environment variable I have to pass? What should be the port mapping? And then, does my application need replication and undoing the deployment? Then you need to create an object called deployment. So that will create a replica set and make sure that your pods are always running. But for that, to access your application or the pod outside the cluster, you might have to create a service, so that regardless of your pod getting recreated, you will have a unique IP that you can access within the cluster or outside the cluster. So for this, you need to create a service object. And then if you have some volumes or some content that you want to share, then for that, you are going to create a volume. So that is where if you want to share this volume across the cluster, then you are going to have a new object called as persistent volume. And again, where are you going to store? So typically, if it is outside the cluster, then you have to use some cloud and create a storage and create a persistent volume object. And for that, define a clean, and then you create your pod, so that automatically it will assign the volume whatever is available. Next, you also have to give health check. So you're going to give both the type of health check, that is readiness and liveness, so that when your application is not responding properly, you can either decide to recreate the container or don't send the traffic to the container. So that is how you're going to define health check. And finally, if your application needs particular sensitive data like your TLS certificate or key stores, then those kind of things you can put it as a secret object. And if you have a configuration file that you want to put, then those things you can put it under config map object. So this is how to create your application deployment. You need to define all these objects and then define it under one YAML file. Getting it? So that is what you're going to do as deployment. And finally, now if you understand, all these objects are going to be within a namespace. So that way you're also going to create a namespace accordingly. Okay. Okay, so unfortunately we didn't have much time to go through that a little deeper. But any questions or doubts so far with the objects, what we have seen are the concepts?
Can we delete namespace? If I delete things, what about objects?
What about?
Inside. Objects inside.
Which objects? These are the objects. Your namespace is an object. Your deployment is an object. Pod is an object. Config map is an object. Secret is an object. Persistent volume is an object. All those things are object. So that is what we started with the beginning, right? So anything in Kubernetes, you are going to define as an object, and all those objects will be available under a namespace. So that is where now to run your container, what and all are the objects you need. That is what I was explaining. So now if you have a web application to run, you need to create an image, and for that you need a pod object, you need a replica set object, you need a deployment object, you need a service object, you need config map object, you need secret object plus persistent volume object, and then health check and namespace object. All of them put together, you will be able to create a container and run.
We can delete namespace.
Sorry?
We can delete namespace object.
Yeah, we can delete it. But you can't delete all the others. The one that you created is what you are going to delete. So for example, I created this namespace called demo, right? Then I can go ahead and delete that also. Now for that, now I'm already on that namespace, so I have to just switch the context back to some other namespace. So I'll go back to default. Okay, and now go ahead. Now again for deleting, I can use the same YAML file. Delete the namespace. But before deleting, you need to make sure you do not have any objects running inside. Okay, then you can go ahead and delete it.
Yeah, okay, okay.
Okay. So yeah, so what we will do is probably I just need one help from you guys. I'll share a feedback link. Okay, so feel free to put your feedback in that. Let me just put it on the chat. You go to this, you should be getting that feedback form. Let me just cross check it. Says HTTPS
Hi, Adam.
yeah, right.
Can you push all the things that we have done today in GitLab?
Yeah, I'll do that. So looks like it's not working. I'll do that.
Yeah, okay. Thank you.
Anyway, if you guys have not practiced the other basic things, like I was saying, please go back to the channel and try to go through the other videos, like a couple of other things that if you want to brush up. Okay. And in case if you have any questions, you can reach our coordinator and they will get back to us in case if you have any questions we can discuss. In the meantime, I'll just give some small assignments and questionnaires to take. So what you guys can do is you can just go through it and practice it. Okay. And in case of any question, probably I can help you address from there. Okay, sure. I'm not sure the link is not working. So let me talk to those concerned people. I'll ask them to share you the mail with the feedback link. So I appreciate if you can just put in your comments. That will be great. Yeah, I've committed it, so you can go back and check this. Right. Yes, I'll share a document with you guys again. Along with these notes, I'll share it to Lakshmi. Probably she can share it with you guys. Okay, fine. I know there's nothing much and it was a long duration. Yeah, feel free to reach us anytime if there's any questions, and we'll be able to answer if you have still any doubts. All right. Thanks for joining us. I appreciate it. Okay. I hope it was a good session. Until I talk to you guys again. Okay. If there's no doubts, then let me just check one last time. There's a new link. This works and give it to you. Okay, so I think the link is there. Yeah, please use this link, whatever I pasted in the chat. Okay, so please put in your feedback. just take 2 minutes after this and send us the feedback. Okay. I appreciate it. Anyway, thanks guys. This was another meeting. Just have 5 minutes left. If there's no question, then yeah, I'll share the document also. But again, the entire notes is available in this GitLab repo, so you can go back and access on that. Yeah, if there is any other topics or questions that we want to discuss, probably you can come through your coordinator. Let's say if we have time, then we can have another session and we can discuss any specific topics that you want. Okay.
Madam, can you share some information about Ingress?
Sorry?
If possible, we have some other session for Ingress concept.
Yeah, that's what again, it's just another 2-3 minutes that I don't think it will be possible. But yeah, we can do it. If you have any specific topics that you want to discuss, I think if you can collect those and let us know, then we can have another session based on that and we can talk only about those topics.
Yeah, sure. Thanks.
We'll do that. Anyway, thanks guys, I just have to drop off. I appreciate it's been more than like 2-3 weeks working. Yeah, thanks for your time and have a good day. Thank you. Yeah, thanks for joining. Yeah, thanks everyone.